So okay guys, I'm just trying to revise my chapter like machine learning, and let's see how we can revise our chapter machine learning. So in my notes I have some kind of a mathematics. So correlation is a statistical measure which tells us how two variables that how much and in which direction they are related to each other. Correlation is a statistical measure which tells us about two variables that how much and in which direction they are related to each other. So we can understand easily that correlation is a type of statistical measure which tells us about two variable that how much and in which direction they are related to each other. So that's actually a correlation. So if I will try to explain you next time, or if I will try to explain it again, so I can say correlation is a type of statistical measure which tells us about two variables, which tells us about two variables that how much and in which direction they are related to each other. So the relation can be positive and negative between two variables. So if something is increasing and another thing is also increasing, that means they are positive. We have a positive relation there. We have a positive correlation. If I wanna give example, so I will try to give an example which will relate to your real world. So first one, if you're what I can say, if something is increasing and another thing also increasing, it means if you're studying more hours there, your marks is going to be increased. Okay, so that's a positive correlation where both are the variables is increasing together. And if I will talk about negative correlation, so I can like usually say that if you're covering your distance, and that's you are covering your distance, it means you are basically uh, decreasing your distance variable. So you are covering your distance, and your, I can say, your speed is increasing. So that's a negative relation where speed is increasing and your distance is becoming uh, less step by step with velocity. So that's actually a negative correlation. So correlation is a statistical measure that tells about two variables that how they are related to each other, in which direction they are going, like positive or negative. So now we are confident with this concept. Okay, now in the machine learning we have a EDA. So I think EDA is like analyzing the data which we have before applying any model. EDA means it's all about to know about your data, that how your data actually looks like, using some of the Python libraries like pandas, and Matplotlib or NumPy. These are the Python libraries that we use to understand that how actually your data looks like. And if you want to see that how your data looks like, so it means you are doing the process of EDA. So that's actually a EDA, that how you are looking your data. You are like finding some pattern from the data. You are some getting or you are extracting some useful information from the data. So that's actually what EDA is like. Uh, EDA means analyzing a data set in detail to understand its structure, patterns, and insight before applying any machine learning model. It's like getting to know your data before using it. So some of the we have steps of the EDA, that is data collection. So how you collect your data, that's the most important part. So you collect your data with different sources. So first one is you collect your data from websites. like SQL, CSV, or Excel, and website. From website, how you collect data? There is a Kaggle platform for data science. From there, you can extract the data, and yeah, so these are like the resources. From there you collect actually your data. So first step is of the EDA is data collection, and data inspection is using methods like head, tail, info, save, describe. That's a data inspection means seeing your data, that how your data looks like and how many rows and column you have. So that's a data inspection. And if I will try to see that how what are the other steps that comes in the EDA. So other step is like missing values, and checking like missing value, that how many missing values you have. So you can easily fill with mean, median, or more, depend on the right discrete or a left discrete. So yeah, these are the like things related to each other. And after that we have a in the EDA we have a duplicate values. If your rows are repeated, so you have to just remove it. So yeah, and after that we have outliers, where we see the outliers using Python libraries, which is very famous nowadays, which is Seaborn. So we have to use the Seaborn for seeing the outliers. So for outliers, we can use there is a concept, or there is a technique, which is a box plot. So using box plot we can easily see the um, our outliers, and we can also remove it based on the data. So yeah, after that we can analyze. It's a kind of a step which is univariate analysis. So it means you can uni means one. It means you can analyze your one column, one specific column at a time, and then it works on like numerical data like histogram, box plot, bar charts. And if you have like categorical data, then you can also count the value using graphs. So that's a univariate analysis means analyzing one column at a time. That's actually a univariate analysis. And bivariate analysis means when you have two or more columns, you are just trying to compare two columns each other, like numerical versus categorical. If you are comparing both variables or columns together, that means it's bivariate multivariate analysis. So yeah, if I tell you example like historical relationship between two or more columns, we can use the scatter plot, pair plot, heat map are used. So then we can see that relation, which is a correlation, find a relationship between numerical. So correlation, or we can say it's a kind of a heat map, where we have a connection between the numerical columns, that how they are increasing like in the positive or negative direction. And yeah, that's fine here. And after that we have a feature engineering, uh, which is the steps of the pandas. So in the feature engineering, we basically make one separate or two or three separate column from the one existing column. If I give you the example, which is date time. If you have a date time column, and that daytime column is actually a text now, and if you want to make it a real date time year, so you have to just use the function which is very famous in Python, which is pd, pd to date time, something like that. We have a function, we have to use that, and then we can easily extract the real date time. Then after that we can extract the real columns from that, which is year, month, days. Then it will be easy for us to know that how your data looks like, and it will be you are just extracting some meaningful things from your data. So we have to use this function of the pandas. So feature engineering also contains one topic, which is encoding categorical variables, like label encoding, I can say. We have to just encode the categorical data like we have a for technique, we have some technique for that. Based on the data, we are going to use this technique. So if we have a natural order, so we are going to use the label encoding. If you don't have any kind of order, then we are going to use I think hot one hot encoding. Yeah, that's the one hot encoding you're going to use if you don't have any kind of natural order, or I can say if you have an unordered uh, or I can say nominal data. So you are going to use one hot encoding. But if you have a natural order like poor, poor, good, excellent, educated, educated, postgraduate, something like that. If you have a so intermediate, so here we have a label. You can see the relation that we have a label. So we are going to use label encoding. So now we are moving to the next topic, which is a regression. So regression is a way to predict numerical column, and it's help us to find how one thing changes when something else changes. And now we will see how you actually create a best fit line. So for creating best fit line, and we have which is a very famous hypothesis, which is y equals to mx plus b. M is the slope here and b is the intercept. So slope is like when you are moving one unit of one unit in the variable x. When you are moving, then how much you are moving in the y. So that's actually a slope. And intercept is like when the value of the x is 0, then where is the best fit line intercepting your y. So that's actually uh, intercept. And we have y equals to mx plus b, where x is input value, we can say input feature or data point, and y is your predicted variable. So we are going to define the theta 0 and theta 1 values. We are going to define the theta 0 and theta 1 values to create a best fit line. But if you use this method, then you are going to become bored. So we will get to multiple lines.